Hey, very good morning, students. Let us look into our next topic called programmable ROM. Before looking into programmable ROM, let us have a small introduction about PLD so that you could clearly understand what is PROM. So, PLD is an abbreviation that stands for Programmable Logic Device. It is an electronic component which is used to build digital circuits, programmable digital circuits. Basically, it's an IC that contains many gates and flip-flops. It is used to build combinational as well as sequential circuits. This PLD is of two types, simple PLD and complex PLD. The simple PLD is subdivided into programmable ROM, programmable logic array, programmable array logic, and generic array logic. Okay, so let us start with PROM. So this PROM, if you see this PROM, which has fixed AND arrays as a decoder and a programmable OR array. Can you see this PROM has fixed AND array and a programmable OR array. So to clearly understand this better, let us get into it. So first we need to understand what is ROM. ROM is a memory device which stores binary information permanently. ROM is a memory and it is used to store the binary information permanently. So once it is stored, we can't change the stored information. So if the ROM has programmable feature, I call it as PROM. So what is PROM? First you need to write what is ROM. ROM is a memory device which is used to store the data permanently. Once it is stored, that cannot be changed. If the ROM has programmable feature, you call it as PROM. Okay, now this PROM is a logic device that has fixed array of AND gates and programmable OR gates. So can you see this is the block diagram of PROM, which has fixed array of AND gates and programmable OR gates. So this is called PROM. So fixed and unprogrammable OR. Clear? Now since which has fixed AND, the AND gates are fixed, you cannot program. If I give n inputs, I should have 2 power n product terms, right? If I have n inputs, I should have AND gates which is 2 power n product terms, or I need to have 2 power n AND gates with having n inputs. So to obtain n inputs, 2 power n AND terms, we are going to implement this using a decoder. That is why here we said that PROM is a fixed AND array. This fixed AND array is constructed with help of what? Decoder. If I give n inputs, it gives 2 power n AND gates. Clear? And it has a programmable OR gate. Now let us see. You can either draw this or you can draw the same thing. Here you can write fixed AND array which is obtained through decoder. Clear? Okay, let us see the first example. This is an example of PROM. It has fixed AND gates and programmable OR gates, or you can draw this block diagram, fixed AND array obtained using decoder. If I give n inputs, I get 2 power n product terms or AND terms. Okay, now see, I have two inputs, A1 and A0. This is my true form, this is my complement form. This is my true form, this is my complement form. If I have two inputs, see here, if I have two inputs, how many outputs, how many AND terms I will get is, if I have n inputs, 2 power n. Okay, so for that we are using a decoder. Decoder is a device which takes n inputs and gives 2 power n outputs. So I give A0 and A1 so that I get how many outputs? 4 outputs. That is 2 to the power of 2. 4 outputs. What are the outputs? 0, 0, 0, 1, 1, 0, 1, 1. So if I give 2 inputs, I get 4 AND gates, 4 output AND gates. So am I done till here? Now what is the OR gate? Which is programmable. So I can have any number of OR gates which I can program. So this part is programmable. This part is fixed. This fixed part is obtained with help of decoder. Clear? So let us design a circuit. Now I'm going to design a full adder circuit, just 3 inputs and 2 outputs. What are the 2 outputs? Sum and carry. What is the input? A, B and C. Now I need to design this full adder using what? PROM. So how will I design a full adder using PROM? PROM has fixed AND gates, programmable OR gates. So before designing, I need to draw the truth table of a full adder. So I have A, B, C, sum and carry. So add the 0 plus 0 plus 0 is 0, carry 0. 0 plus 0 plus 1, sum is 1, carry is 0. 0 plus 1 plus 0, sum is 1, carry 0. 0 plus 0 plus 0 plus 1 plus 1, 1 plus 1 is 10, sum 0, carry 1. So fill the truth table. After filling the truth table, write the minimal expression for sum. Sum is equal to, see the position where it is high. This is 1, 2 and 4. So sum is 1, 2, 4 and you have high here which is 7. So 1, 2, 3, 4 ones. So 1, 2, 4 and 7 for sum. What is for carry? How many carries you have? 1 term, 2 term, 3 term and 4 term. What are they? This is 3. This is your 5. This is your 6 and this is your 7. This is 3, 5, 6, 7 is my carry. Sum is 1, 1, 2, 4 and 7. I am done. Now I am going to design a PROM. So you know PROM has fixed and programmable OR. So fixed AND is obtained with help of decoder. If I have 3 inputs, I use 3 input decoder. If I have 2 inputs, I use 2 input decoder. Since I have 3 inputs, I am using 3 input decoder. So n input, 2 per n outputs. 3 inputs, 2 to the power of 3 is 8 outputs. So A, B, C are the inputs. 0, 1, 2, 3, 4, 5, 6, 7. 0, 2, 7 which is 8 are my outputs. Can you see this? What is this output? A. First output is 0, 0, 0. 0, 0, 0. That is A bar, B bar, C bar. Second one is 0, 0, 1. Next is 0, 1, 0. So these are the outputs. So draw the line. Clear? Now this is done. This is what? Fixed AND gates. Now come to the programmable OR gates. How many outputs you should have? Sum and a carry. So one OR gate for sum, one OR gate for carry. Now do the connections. What is sum? 1, 2, 4, 7. So go to 1, go to 2, go to 4 and go to 7. Connect the fuses. Keep a cross mark connected to sum. What is the output for carry? Carry is 3, 5, 6, 7. Go to 3, go to 5, go to 6, go to 7. This is my carry. So now what is that I have designed? I have designed a full adder using what? A programmable ROM with fixed AND gates with help of decoder and programmable OR gates in the other end. This is an example for PROM